Hello guys, so today I was solving this problem. This was the problem of the day from LeetCode, which is increment submatrices by 1. So in order to solve this problem, you guys need to know two concepts. Okay, so one is sweep line algorithm. Okay, and other is how can you do prefix sum in uh, in a 2D matrix. Okay, so these two concepts are needed. Prefix sum is something like you just need to know the idea, so that will help you to apply sweep line in a 2D matrix. Okay, so yeah, you can check out some tutorial or maybe some blogs on this algorithms. So there is popular code forces algorithms for prefix sum, so you guys can follow maybe this, practice some problems on that. Okay, I will explain on in for both of them, but I don't think that will give you much more idea unless you guys try the question, like try out some question on these concepts. Okay, so I will highly recommend like maybe going through this article. Why this is in Russian? Let's select this. So yeah, but yeah, let's discuss the problems. So the problem states that I have been given a 2D matrix. Okay, this thing, let's copy this, we can paste it here. Okay, so I have been given a 2D matrix, and it's a square matrix, so the dimensions are n and n, like n rows and n columns, and initially that matrix have all the cell values zeros. Okay, then the question has given us some queries. Okay, now the queries represents now each query in the query list represents a rectangle. Okay, now in order to represent the rectangle, so they are using the top left and bottom right like structure. Okay, so you can think of it, so if I want to represent this rectangle, okay, so I can represent this rectangle by saying that, hey, uh, get the cell at, let's give the coordinates here, 0 0 1 2. Okay, so I can say my rectangle starts from 1 and 1. Okay, 1 and 1 coordinate, and it extends up to 1 to 2. Okay, so the one index row to the second index column. Okay, so yeah, I can represent this rectangle in this form. So this is how they have given the queries. Okay, now what we need to do is, so for each rectangle the question has given, we have to consider the rectangle in my grid and increment all the cell values that are captured by the rectangle by +1. Okay, so yeah, that's the question. So I have to process all the queries, and then I have to return like I have to process all the queries in the grid, and whatever cell values got updated, okay, I have to return the grid. Okay, so you can see here in this example, so initially I started with this n cross n grid. Okay, then I can see my first query is 1 1 1 2 2. Okay, so the top left coordinate, like the top left cell coordinate of the rectangle is 1 1, and the bottom right cell coordinate is 2 2. Okay, and so yeah, this is my rectangle. So if you guys know, like all squares are like rectangles only. Okay, so square is a subset of rectangle. So yeah, whenever I'm saying a square, that's kind of a rectangle here. So yeah, this square that you're seeing, it's a rectangle, and yeah, so in this rectangle, whatever cell values we have, so they were initially 0. So after processing the first query, they got all update to 1 1 1. Okay, then my second query is 0 0 1 1. Okay, So here if you see, so my top left coordinate is this, okay, my bottom right coordinate is this, okay, and I incremented by 1 to all the cells, okay. Now this cell was updated in my first query 1, so when I did another +1 by when I was doing the second query, it got updated to 2, okay. So this is how the final matrix looks like. So yeah, so if you think of it, um, so you can think of a brute force kind of a solution where we have been given the rectangle coordinates, right? So I can simply write a for loop. What happened? Is it deleted? Yep. Yeah. So yeah, I can simply iterate over the rows and columns covered by the rectangle using something like this. So for R starting from R1, okay, ending with R2, R plus plus, then for for C equal to C1, C less than equal to C2, C plus plus, C plus plus, cool. So I can do something like grid of R comma C plus plus. Okay. So I'm saying G here, so you can take this mat as G here, okay. So this I can do for each rectangle, okay, and I can do for all the queries, okay. So for R1, R2, for R1, C1, R2, C2 in my queries, okay, I can do this thing. So this is the brute force solution. So if you think of it, the time complexity here will be the number of queries I have, let it be q, and the number of iterations I have to do here, okay. So you can think of it, so if I have been given q queries where every query is representing the whole matrix itself, okay. So this R1 and R2 distance is, let's say, n itself, okay, and here the column and the C1 to C2 distance is n itself. So that's kind of my worst case, okay. So I can say n square will be the time complexity of this nested for loop, okay. So this will be my brute force time complexity, okay. Now if I look at the constraint, so queries can be till 10 to the power 4, okay, and n is 500, okay. So 5 into 10 to the power 2, okay. If I do a square here, so this will bring to 25 square, so 10 to the power 8, okay. And to simplify it more, so 2 point not it should be equal to 2.5 times 10 to the power 9, so 2.5 billion operations I will be needing for my brute force solution, okay. Now this will give you a happy TLE, okay, because generally in every maybe in a contest or in every question, so they generally look for time complexity where the number of operation will be less than equal to 10 to the power 7. Some of them allow till 10 to the power 8, but this case is like highly unlikely, okay. You will find rare cases where contests are allowing 10 to the power 8 operation, okay. So it's a general idea to keep the number of operation in order of 10 to the power 7, okay. So can we do something better, okay. So yeah, so how can we do it better? So we know we have to process all the queries, which means this loop is necessary, okay. So we will have 10 to the power 4 with us, okay. Now can we somehow simplify this, like this thing, this updation, okay. So if we do this thing along with each query, so that is bringing, like, that is increasing our time complexity, okay. So can we do some kind of a linear thing here, okay. So yeah, in order to do it, so you guys need to understand how sweepline algorithm works, okay. So what sweepline algorithm states that, let's say you have an array, let's say this is 1 2 3 4 5 6, okay. and you have been given some queries. Let's say the queries are I will put some indices 0 1 2 3 4 and 5. Okay, let's say I have been given some queries, and the queries examples are let's say 1 and 3, okay, 2 and 5, and let's say 1 and 2. Okay, so these are my queries. So what is the definition of a query here is, so you have to select all the elements starting from the first index till the third index including. Okay, and you have to do some constant updation. Okay, so the constant updation can be like incrementing to some plus delta value, something like that. So let's simplify it to like +1. Okay, so for each of this range queries you have to do +1 over all the elements covered in this range. Okay, so yeah, so you can see some kind of a similarity here. So here this problem is giving us rectangle, but in sweepline statement, which is generally for 1D arrays, so we deal with 1D array as well as 1D queries. Okay, so yeah, so in order to solve this, we don't need to like iterate over all the queries and in them iterate over all the elements covered by each queries. So we can apply sweepline algorithm something like this. So the sweepline algorithm works with some pre-processing, bad handwriting, pre-processing plus prefix sum. Okay, so yeah, let's talk about pre-processing. So what pre-processing we do? So in order to do pre-processing, we create an array with an incremented dimension. Okay, so here I have 6 elements, so I will create an array with 7 dimension. So let's create this. So let's create 7 dimension, 0 1 2 3 4 5 6 and 7, 2 3 4 5 6 and 7. Okay, so what do we do is, so whenever I have this query 1 and 3, I will add 1 to my starting index. Okay, and I will do a -1 to the ending +1 index, which is 4 here, -1. Okay, so yeah, like that let's do it for all the queries. So 2 and 5, so 1 here and 5 plus 1, so on 6th index I will do a -1. Okay, so now you can think of like why I need the 7 index. So let's say I have a query 1 and 6 where I have to do +1. So yeah, let's do it for 1 and 2. So for 1 and 2 I will be doing 1 here, so 1 is already there, so I will increment it to +1, and for 2 plus 1 I will do a -1. Okay, now for the last query again 1 and 6. Okay, so a +1 here. Okay, and at this 6 plus 1 index I will do a -1. Cool. Now what I will do is, I will do a prefix sum for this pre-processing data structure. Okay, so I will start from left and keep on adding the previous element to the current element. Okay, so this will be like 0 0. Okay, I will start from left, so this is 0. Here I have 3. Now 3 plus 0 is 3. Okay, now here I have 1, so 1 plus the previous guy, which is 3 here, 4. Okay, so let's create this array itself. 1 2 3 4 5 6 7. Okay, then I have -1 here, so -1 plus the previous element result, which is 4 here, so 3. Okay, then -1 again, so -1 plus the previous element result, which is 3, so 2. Then I have 0, so 2 again. So this I'm doing prefix sum here. Okay, so prefix sum is basically like um, prefix sum of I is basically prefix of I minus 1, okay, the previous result, plus the current array element. Okay. So yeah, right now this array is this guy, my pre-processed data structure. So there I'm running the prefix sum. So yeah, so where are we? So we are 2, then I have this minus 1. So minus 1 plus the previous index is a result, which is 2, so 1 here, and finally I have minus 1. So minus 1 plus the previous index result, which is 1, so 0. So you can see I got all of my updates. Okay, now when I add up this prefix array to my original array, I will get my final answer. Okay, so if I do 1 2 3 4 5 6, oh yeah, I think 6, right? Oh yeah, here index was 5, 6. Oh, I don't have a sixth element, but I did this, so it's a wrong query. So I can put one element here. So let it be 7, let's say. Cool. So yeah, 1 2 6, 7th here. Okay, and I simply add them up. So you will see that when I process this query over this array, I will get the same result what I'm getting here. So 0 plus 1 1, 3 plus 2 5, 4 plus 3 7, 3 plus 4 7 7. Okay, so many thalas. Okay, 6 plus 2 8, then 8. Okay, so if I run this query over this and like do the same thing for all the queries here, I will get this final array. So yeah, this is my final result. So yeah, this is my sweep line algorithm. Now how to apply, so how to use this idea on this question. So we can do something like, so we have been given rectangles. Okay, so in each rectangle I will be having rows. Okay, so I can apply the sweep line algorithm for every row. Okay, so I can show you how it works directly in the code. So this will look something like, so let's take the dimension. I have already given n. So here first I will create my sweep line pre-processed array, how it will look. So I will be creating a 2D array. Okay, so I will call it vector of intent, and let's call it prefix sum directly, n plus 1, n plus 1. Okay, then what I will be doing, so I'll be doing this pre-processing first. Okay, so I will iterate over all the queries, auto queries. Okay, then I will say r1 equal to q0, c1 equal to q1, then int r2 is equal to q of 2, then c2 equal to q of 3. Okay, so yeah, so the idea is, so I can apply this sweep line algorithm for all the rows present in my rectangle grid. Okay, so yeah, what I will do is, so for row starting from r1 and row equal to r2 plus plus r, I can do prefix sum of r plus c1. I will increment that to plus 1, and prefix of r c2 plus 1. Okay, I will be putting this minus 1 to stop the increments. So what I did in the sweep line thing. So yeah, so what I'm doing, so for every query, so I have the set of rows in which my rectangle is there. Now in that I am iterating over all the rows. Okay, and I am putting this update value over the starting index, okay, which is on C1, and I am putting the -1 at the stopping index, which is like C2 plus 1. Okay, so yeah, this is what I did here. Now I can run the prefix sum and finally update my answer array. So let's create an answer array. So vector of int ans. So it will be of dimension n and n. Okay. Now I can iterate over all the cells. So for r equal to 0, r less than n, r plus plus. For column equal to 0, column less than n, column plus plus. Okay. So yeah, let's update our prefix sum first. So prefix sum of r comma c equal to prefix sum of r minus 1 c, the old result. Okay, so I will be adding up with my old result. So prefix sum of rc. So I don't need this, I can simply do a plus here. So, and yeah, this is -1. So yeah, so I'm treating every row as my 1D array of my sweep line, and I'm just running the prefix sum there. Okay, so yeah, you can see like my c is starting from 0, so I can have a check here. So if c is greater than equal to 1 only, I will run the I will update the prefix sum, and finally I will add it up in my answer array. So prefix sum of r comma c. Cool. If I do the ans, and let's test it with test cases. So here it says, prefix sum, here is prefix sum, prefix sum, prefix sum, prefix sum. Cool. So it passed the initial test cases, and it will pass the like it will pass all the test cases, because so if you look at the time complexity here, so there is number of queries. Now I'm just iterating over all the rows covered by my current rectangle, okay, which can be at max n, so q times n here. Okay, that's all. So but if we look at our brute force, I was iterating over the rows as well as the columns. Okay, so with sweep line I have get like written of this. So yeah, so the q times n square get reduced to q times n, so which is like 10 to the power 4 times 500, which is 10 to the power 2, which is 5 times 10 to the power 6. And then I'm doing like iterating over all the cells, and basically doing the prefix something, which is again this is like constant, this is also constant, and there is this only for loop, which is n square. Okay, so q times n plus n square, and this is acceptable, which is like n square will give you what, 500 square, which is 25 times 400, which is 2.5 times 10 to the power 5. Okay, so this will, so which will be coming close to like 5 times 10 to the power 6 only if I add them up. So this is acceptable because it is less than 10 to the power 7. So yeah, we are good, we are also in the top percentile, but yeah, like I said, so don't trust this chart. Okay, so if you are in an interview kind of a scenario, the interviewer will tell you, hey, can you get rid of this also? Okay, can you think of a way in which you don't need to iterate it? Okay, so this is where you have to have an understanding of how prefix sum works in 2D matrices. Okay, so yeah, this is where we will apply the idea of prefix sum in 2D matrices and implement sweep line over them. Okay, So let's take this example itself. Okay, so if I think of doing the prefix sum, okay, or let's say if I think of what is exactly happening in my rectangle update. Okay, so my rectangle is something like this. Okay, so it is giving me the starting coordinate and it is giving me the ending coordinate, and what I have to do is I have to increment 1 to all the cells. Okay, as well as I have to increment 1, like you can think like I have to increment 1 in all the cells. Okay, so in order to do that, I can do it like row wise like this. Okay, or I can do it like column wise like this. Okay, so can we think of some way in which we can apply the same logic of sweep line here? Okay, yes we can. Okay, so row wise we have seen, so I can put a 1 here. Okay, and in order to stop the update when I'm going from left to right, I can put a -1 here. Okay, and if I do this for all the rows, I need -1 for here as well as here. Okay, but think of what will happen if I do it uh, in the direction of column. Okay, I put a 1 here. Okay, and if I do it column wise, then I need to put a stopping index at here. Okay, so let's expand this one, this, and yeah, like this. So yeah, so if I am doing it column wise, I need a stopping index for every column like this. Then if I'm doing it row wise also and column wise also, okay, so all the values will be added up twice, right? So this, but what will happen is I'll be able to do it in a single iteration, or like in a single traversal in my grid. Okay, so yeah, so just like in sweep line, what we were doing, we are putting the update value at the starting index, and in order to stop the update when I'm going from left to right, I'm putting a minus of that update at the last index plus 1 index, right? So yeah, so just imagine it putting it here. Okay, for doing it row wise also and column wise also. Okay, so yeah, so if I want to do the sweep line in a matrix, okay, I can put a -1, I can put the update value here at the starting cell, which is here. Okay, and if I run it like this as well as this, okay, so I can somehow get the feeling of sweep line in the matrix itself. But the problem that I'm facing is, so the values will get the contributions twice. Okay, so yeah, now coming to this cell. Okay, so when I'm doing it row wise, I need a -1 here, right? But when I'm doing it column wise, this guy is again getting a -1, so that will increment this value to -2. Okay, so how to do it now? So to prevent this mistake, okay, because I need only a -1 here, right? So in order to prevent this mistake, whenever we are putting a -1 here, a -1 here, okay, we can do a +1 here. Okay, so the final uh, update matrix will look something like this. So I'm doing a -1 here. So yeah, let's do it again. Okay, so I'm putting my 1 here. Okay, and in order to stop the update from left to right, I'm putting a -1 here. Okay, now when I'm doing the column wise update, in order to stop the update in column wise, I'm putting a -1 here. Okay, so when I'm parallelly processing them, okay, this guy will get -1 from both sides. Okay, so in order to prevent that, I can put a 1 here. Okay, so that when I'm doing update from here, okay, this guy will get neutralized, but when I'm doing a column wise update, okay, this guy will get the update value. So yeah, so this is how you can put the sweepline algorithm in a 2D matrix. Okay, now how to do this? Like, I have put the updates here. Okay, but how to actually run it and get my like the final update value? Okay, so yeah, so if I want to use this matrix and only use this two nested for loops, like this thing, if I bring this code here, let's remove this. Oh yeah, I can do this. So if I want to use this uh, process metrics, just like in sweepline we have this concept of process metrics, and then we run the prefix sum. Okay, and when we run the prefix sum, we usually use this two nested for loops to iterate over all the cells, and there we use our process metrics. Okay, there we calculate the prefix sum as well as we update the answer value. So yeah, that's how the sweepline algorithm works. So yeah, let's apply it on this 2D matrix. So yeah, I have this process matrix. So how to update this? Okay, so I can observe that for every cell, okay, I will get a I will get a update from above, okay, and I will get an update from the left. Okay, so from both sides I will get an update. Okay, but if you think, so how did this cell got its update? Okay, this cell must be getting its update from this guy's top as well as this guy's left. Okay, and if you think about this guy, okay, this guy must also have gotten its update from its top as well as from its left. Okay, now we can observe that this cell is kind of contributing to our current contributions. Okay, so for this cell, okay, let's use a different color. This cell as well as this cell are acting as contributions. Okay, but in these contribution, when these contributions were updated, okay, that time this cell was present for both. Okay, so this cell was acting as a left contribution for this cell, and when this guy was updated, this cell was acting as a top contribution, like top cell, right? So yeah, so if I'm using this, so if I'm using this to updates for this current cell, this guy will be counted twice. Okay, so in order to remove it, I can simply subtract this value. Okay, so my final prefix sum update will look something like this. So let's call it PS. So PS of R C, it will look like uh, plus equal to PS of my top cell contribution, which is R minus 1 C, plus my PS of R comma left contribution C minus 1, subtracted with the diagonal contribution PS of R1 C1. Okay, so this is how my prefix sum will get updated. Okay, once I have created this pre-processed data structure for my sweep line, I'll be using this algorithm, okay, or this updation strategy to update my prefix sum. And finally, for my answer, I'll be setting answer of RC equal to prefix of R and C. So yeah, so how it will help is I can create this processed array with constant operation. It's simply like putting ones at the ones and minus one at the proper places. Okay, and that I have to do it for all the queries. Okay, so it will be of number of queries time complexity. Okay, and this prefix sum updation will take the time complexity of the number of cells I am traversing, which is this for loop, like this nested for loops. So this updation is constant, and this assignment is also constant. So the only time complexity contributor is this nested for loop. So by this, the overall time complexity will get reduced down to number of queries plus the time complexity of iterating over all the cells, and this will be around 10 to the power 4 plus 500 square. Okay, which will be in the order of 10 to the power 4. So yeah, so let's code it up. I think after coding you guys will have a better understanding. So yeah, so I have created my prefix sum. Okay, and here I will remove this. Okay, and I will create my preprocessed, so I will use this prefix sum as my preprocessed array. Okay, so what I'm doing, so I'm putting a I'm putting a 1 at the top left cell of my rectangle. So prefix of R1 C1 plus plus. Okay, then I'm putting a -1. Okay, at for this row wise updation, so which is R1 C2 plus 1 -1. Okay, because you can think of like here I have C1, this thing is my C2. Okay, this is my R1 and this is my R2. Okay, so this is how my rectangle looks. Okay, so yeah, so I have to keep a -1 at C2 plus 1 index, as well as when I'm doing my column wise direction updation, I have to keep a -1 at R2 plus 1. So yeah, so this cell will be my R2 at R2 plus 1 in order to stop the update when I'm doing when I'm falling from top to down. So R2 plus 1 C1 minus minus. Okay, then finally, so when I'm doing this stopping criteria in both the direction, this intersection part will be having -1 twice. So in order to prevent that, I'll be doing R2 plus 1 C2 plus 1 plus plus. Okay, so how it will be getting twice? So because when I'm running this prefix sum, okay, so this guy will be getting the contribution from the top as well as from the left. Okay, and it will be becoming -2. So that's how. So yeah, so we need only this in order to create this array. So this thing is done. Now let's update our prefix sum code. Okay, so I'll be keeping this line. So let's update this thing, or let's write something like this. So what is my top contribution? Okay, what is what update I'm getting from my top cell, which is prefix oh, I'm forgetting about prefix sum. That's my variable. Paste prefix sum of R minus 1 C. Now here R is starting from 0, so I can do a check here. If R is greater than or equal to 1, then take this, otherwise take 0. Okay, then what update I'm getting from the left? So here this will be like prefix of R C minus 1 Okay, so since I'm doing c minus 1 and c starting from 0, so I can do a check here like c should be greater than equal to 1. And finally, for my diagonal contribution, okay, so I need to do prefix of r minus 1 c minus 1. Okay, now I need to check both the condition. R should be greater than equal to 1 as well as c should be greater than equal to 1. Yeah, then I will finally do my prefix update. So prefix sum, yeah, prefix sum of r comma c will be my top contribution plus my left contribution, and let's remove the diagonal contribution. Okay, because this guy will be contributing twice, because this guy has contributed in my top and left. Okay, so in order to capture only one copy of this contribution, I'll be removing one copy. So yeah, so prefix sum this, then assigning this. Okay, and finally returning the answer. Should work. Let's see. We got wrong answers. Okay, let's check. I got R2 here. Okay, let's see. I got R1 and C1 here. Okay, then R1 and C2 plus 1 will get minus 1 here. Okay, then R2 plus 1 in the same direction of C1 will get a minus 1 here. Okay, then R2 plus 1 and my final C2 plus 1 will get a plus 1 here. Okay, in order to prevent this. Okay, so this thing is correct. Okay, let's check the, yeah, then I have answer here. So iterations are good, so let's look at the top. So if r is greater than equal to 1, I'm getting this. Okay, r1 this, otherwise 0. Okay, now for the left thing, so for this current cell in the same row, c minus 1 will give me my left contribution, and for the diagonal thing, so r and c, prefix of r minus 1 c minus 1 will give me my diagonal contribution that I have to remove here. Okay, should work. Why it is not working? Because let's look at what I'm getting in prefix sums. So I'm seeing all are zeros for both the test cases, which means my answer is taking only 0 values, which means this condition will be updating. Prefix of this thing is 0. Let's check. Everything is 0. Let's see. Okay. Let's look at the prefix sum. Yeah. I'm getting the values here, which means should work, which means something is wrong here. Let me check. Okay, got my bug. So it's a silly plus equal to have to do. Okay, because for the first time it may happen like this becomes 0, this becomes 0, this becomes 0. Now that 0 is like passing through all the prefix sums, so should work. Yeah, let's remove this. Now let's run this. Okay, so we can see some improvements. I'm in the first stick now. So yeah, let's quickly do for quickly do for Go. Okay, so let's create a prefix sum. So make of this will be an array of n plus 1. Okay, now for every index, let's create our answer array also. Answer make of this of this of this of n. Okay, then for index of in yeah, I can use directly this index in range of prefix sum. I'll say prefix sum of index equal to make of this plus 1. So all will be initialized with 0, and similarly for ans idx equal to make of int of this and n. Cool. Then let's do the same thing what we did for our C++ code. So creating the processed array for our sweep line. So for queries in range of queries, so let's destructure it. So r1 c1 r2 c2 is q0 q1 q2 q3. Okay, cool. Now let's use them. So I'll say prefix sum of r1 c1 plus plus, prefix sum of r1 c2 plus 1 minus minus, then same thing, prefix sum of r2 plus 1 c1 minus minus, then prefix sum of r2 plus 1 c2 plus 1. I will do plus plus. Cool. So processed array done. Then I need to run prefix sum. So for r in range this to n r plus plus, for c in range this c then c plus plus, and yeah, so here I can capture the top contribution. Yeah, so I can initialize top, left and dag to 0 0 and 0. I can write some ifs here. So if my r is greater than 1, so top will be set to prefix sum of r minus 1 to c. Then if c is greater than or equal to 1, then left will be set to prefix sum of r of c minus 1. And finally, if r is greater than or equal to 1 and c is greater than or equal to 1, then dag will be set to r minus 1 c minus 1. Okay, then finally I will update my current prefix sum of for r comma c equal to top plus left minus the diagonal contribution, and I will update my answer of r comma c to the prefix sum of r comma c. Cool. And yeah, finally I will return my answer. Should work. I hope so. Ha. runtime error. Yeah, because I'm initializing to +1, so n+1, so I can simply have a check here. Index is less than n only, then update my answer. Yeah, done. Let's go. Cool. Now let's get rusty. Cool. So let's create a mutable reference for our prefix sum. This is equal to vec exclamation mark. Very weird syntax, but yeah, let's go with it. This, let's create n+1. Okay, and I need to initialize all of them with 0, and this I need to initialize with n. And similarly, I have to do for ans vec exclamation vec exclamation. This I will be initializing with 0, but with n and with n. Cool. So my prefix sum and my ans are initialized. Then I just need to do the same thing to get the preprocessed df. So I will say for query in queries. So let's destructure it. And yeah. So one more thing. So this n is either redo. So in order to use it as use it like this, so I have to create it usize, and I don't want to put usize in every whenever I'm using n. So let's create a separate n and say like I want to use this capital N as n usize data type, and let's update our n's to, okay, let's do n to capital N. Cool. And now for queries in this, so r1 c1 r2 c2, it's my q0 as usize, and q1 as usize. Let's bring them down. Okay, let's use this. Let's bring them down. Let's do it r2, let's do it c2, let's do it 2, let's do it 3. Okay, cool. Now I need to do the same stuff for this array. Cool. So r1 c1 will get plus equal to 1. Okay, let's copy this. Copy. Okay, then for r1 to c2 plus 1, okay, I need to put the stopping criteria here. Then for r2 plus 1 to c1, I need to put a stop here. Now in order to prevent the update from both sides, I need to do r2 plus 1 and c2 plus 1 position with a plus 1. Okay, cool. So up to this we are all good. Now let's finally run the nested for loop to update our prefix sum and update our answer. So for our in range 0 to n, then for c in range 0 to n, and yeah, then I'll be updating my prefix, and before that I will be creating top, left and diagonal. So let mut of top left, or I can say top equal to, if r is greater than 1, I can say prefix sum of r -1 c, then else 0, then let left equal to if c equal to 1. It'll be better if Rust can have some kind of a ternary operation, because if it is claiming that it's very like advantageous compared to C++, then yeah, I think it should have. But yeah, then people will start using ternary operator like mad people, and the code will be not readable. So okay, it is what it is. So yeah, prefix sum of r -1 c minus 1, then else c. Cool. So I have top left and diagonal contributions. Then I will be updating my prefix sum of my current cell. So yeah, this I need to use capital N. This I need to use capital N because I need U size here. So yeah, prefix sum of RC will be plus equal to top plus left minus diagonal. Then answer of R comma C equal to prefix sum of R comma C. And I can return ans, fingers crossed, everything works. Do I need to check it? I'll check it if my compiler says something is wrong. Yeah, my compiler says something is wrong. Because I didn't do a +1 here. Duh. Should work. Didn't work. Okay, why? Out of bounds. Interesting. The len is 3, but the index is 3. This is something new. The len is 3. Which thing is 3 here? Yeah, why I don't need this. Yeah, I think it's because of late night. Yeah, let's submit this, fingers crossed, everything should work. And it worked. Cool. So yeah, I think it's a pretty lengthy video, but I thought like it will be better if I can explain you people how sweepline and the idea behind prefix sum is working here. So yeah, prefix sum for 2D, you can check out all these questions here and the concepts that that has been given. Okay, so it's a pretty standard algorithm, but yeah, you can only grasp it once you have solved plenty of problems on these two concepts. So yeah, I hope you guys learned something new. If you like this video, then please do like and subscribe. So yeah, thank you all. Good night.